Welcome to another episode of the Concrete Logic Podcast, and I have a returning guest. You all know him. He's the famous Dr. John Belkowitz from
Going on,
Intelligent Concrete. We're Intelligent Concrete today, not Eddie Stone, right?
Actually, we're CIM.
Oh, yeah. CIM, Concrete Industry Management, for folks that don't know that. Texas State.
There you go.
Yeah.
Got to get one of the guns out. Oh, I shouldn't say that in New Jersey, should I? No, they might be breaking down the door here in a little bit, just to let you know.
That would make the podcast exciting.
That would make the podcast exciting, and my collar is not popped. Just to let you know, we haven't taken the dog on a WALK.
Oh, that's his problem.
And he is crying right there. So if you hear somebody crying, it's our dog who is giving us S right now. But good morning, everybody. And Ryan, thank you for the shirt from Texas State. And go Bulldogs. Is that their mascot? That's not their mascot.
I don't think that's their mascot. I can't remember what it is. I had him on the podcast too. I couldn't
Go
tell you what.
Knights. I don't know if it's a night either. I'm just going to say.
Go
Go
Concrete.
Ducks.
It should be like Concrete Dudes or something.
Concrete Dudes.
Yeah, that's probably not PC either. All right. I know you got something to get to, so let's not waste a whole bunch of time. But today we're going to talk about the top 5 concrete technologies, Dr. John's top 5. Is that what we're going to call it?
No, that's not what we agreed to. And I've got witness. We could check the transcript. Were you recording before we started this?
No.
Oh, that's
not.
a shame.
That's where all this.
That I'll say that you're starting off with your top 5, and then I'm doing my top 5. Whitney?
Well, am I doing a top 5?
No, Seth is supposed to do his top 5 first, right?
Yes.
See?
Oh,
Yeah.
man.
Now,
My top 5. I don't even think I have 5.
listen, we're not going to hold you to this. If you wake up at 2:00 in the morning, you're like, I should have said this. What's your favorite movie, or what book would you bring on an island? You never answer it the right way when you're on the spot. But the ones that you do have when you're on the spot, they're the ones that are at your core that you can remember no matter what, or by accident.
Yeah. Gotcha. All
Go
right.
ahead.
You want me to go first?
That's what Whitney said, not me.
Okay. The first thing that pops in my head, I don't know how, I wouldn't call it new. It's newer, and I think it gets more favorite technology. Okay. I'd put out the laser screed out there. That's my favorite.
Is that number 5 or is that number 1?
I think we should count down from 5.
Go ahead, laser screed.
Laser screed. Reduction of labor. Also provides the results of it provides a higher quality product. It also helps greatly with the standards that some of these owners' clients have now that are out there. Big box guys, Amazon and such, they have high FF and FL tolerances that you got to meet. And really, I don't know how you would do it without a laser screed.
What you need is a bunch of guys on knee boards, one with the steel, one with the mag going over it, and that'll flatten it out.
Yeah, yeah.
I was joking.
I'm sure they did it somehow like that. And place and finish folks, just like everybody else, but I think to the extreme, they're hard to replace. Once these guys are gone, I don't see a bunch of kids scrambling to place and finish concrete.
So the labor force, right?
Yeah. And they're just cool. They're cool to watch.
There's logic behind that, man.
Yeah.
If your toys and tools are cool on the job site and it helps you enjoy your job. I had a friend who used to work on satellites. He used to have a computer game that would have little robot arms that went out and fixed satellites. And you think he would, like, every kid's dream is to play, you have a video game that actually does something in outer space. And he's I remember the day he told me he was getting out of the field. I asked him why. Like, you have an amazing job. And he goes, "What? You think I wake up every morning, jump out of bed, and go satellite?" And I swear I shouldn't laugh because we were in a bar. He was crying. He was drinking. I hate this job. I'm like, how do you? But if you have a cool toy, you love going. "Yeah, I get to go on my laser screen. That's awesome." Like, there's
Yeah.
those dragon laser screens too.
Yeah, I got to use them the first time,
And
within
that's
the
like a
last 4 years. Yeah, those
great
things
number
are cool.
5. Okay. What's number 4?
Oh, what you gotta share your number 5 now.
Number 5 is really boring for me. It's lightweight concrete. And
Mhm.
it's not the sexiest concrete out here, but the American Society of Civil Engineers at one point were really big into concrete canoe. And back in, what was it, 2001, 2002 timeframe, that's where I fell in love with concrete research. I'd already been doing concrete work as a young kid, but lightweight concrete and the concrete canoe competition started my, like, I would literally, at the Air Force Academy, I would break into the lab at night with my buddy Andy Gillis to work on we had to remove, I'm not going to say how we broke in, but they would lock the lab up, and not on purpose. This was the only time, like 7 o'clock, 8 o'clock at night, for us to go down to the concrete lab. And the Air Force Academy has a huge effing concrete lab, and we would get to work on lightweight mix designs, and it was awesome. I had a lot of fun. I had no effing clue what I was doing. I was just throwing materials in and waiting for it to harden and be like, "Dude, check it out." And I learned by trial, and I just had the best time ever. And then we made the concrete canoe, and it almost sank a couple of times. And then we came back the next year, and our first year's canoe was called the POS, Pride of Service, man.
I
So
thought you
the
said
next year
POS.
we called it Troyer's Destroyer after a buddy of ours had passed. And then I can't remember what the next one was, but yeah, we really loved it. Concrete and canoe was awesome. So that's my number 5.
Lightweight concrete.
Yeah. And you could do so much with it. Blast absorbing, use it for energy absorption for waves, and then put some energy harvesting into it. Tidal influxes, you can use it to control. There's so many. Blast absorbing. We spent a long time. That's one of the first products we as a company ever developed with lightweight concrete. That was my first. I went from lightweight concrete for the concrete canoe to lightweight concrete for blast absorbing properties. And that was one of our biggest breakthroughs. That really what's got us our funding as a company to start off. And we sold one of our major mixes to a certain agency years and years, 15 years ago. So that was our, first project ever. And it was basically the technology that I had been working on when I was working at Lafarge. I had this big closet, huge closet right in the front, like the weirdest apartment, the Grand Lowry Lofts. I turned it into a little research laboratory, and you would call companies that had all these different 3M, other companies that had lightweight aggregate, and then I'd buy cement. I'd ask some of the sales folks for samples, and I would have a Hobart mixer, which really was a KitchenAid, and I'd mix up samples in my apartment to figure out these mixes. And that's when I was learning concrete mix design at Lafarge. So I was using the techniques I learned at Lafarge to get into lightweight for blast absorbing. Then I worked at the U.S. Army Corps on identifying the properties, and University of Denver had a blast range. So yeah, lightweight concrete.
Huh.
Your turn.
All right. I should have disclosed that maybe these aren't in order, but I'll try my best
Whatever.
to keep
Yeah.
them in order. I'm gonna go with it's not necessarily concrete, but goes in concrete, welded rebar mats.
Really? That is why? Like the rollout ones?
No, not wire mesh. I'm talking about, rebar. So typically, again, going back to, an Amazon project that I was on, they wanted you to tie a bunch of number 4s and 5s for slab on grade reinforcement, which is that's a lot of ties for a rod buster to do.
Good.
So we converted that to welded rebar mats, which those
Wow.
are prefabricated in a shop and then shipped to you in big mats. I'm trying to remember what the size of these things are. They're massive. They're like 6 or 8 foot wide by 14 sheets. They weigh a couple 100 pounds each, but it's basically you're throwing a mat of rebar down that's already pre-tied, and it's pretty cool technology. I would consider that technology under the prefab kind
Oh
of
yeah, dude.
tech.
It to some degree, if you look at your list from before, reduction of labor force, higher quality product, help regulate stricter standards, there's a theme between your first one and your second one.
Yeah.
That's what I
Okay.
like to do. I like to look at people's lists
Uh-huh.
and then try to figure out, just like your hats behind you and your paintings, I like to see the theme and the trend in things to describe you as a person. Okay. Have you seen the same thing, the welded rebar mats, but in a carpet roll? And they roll it out on the job site?
I've seen that. I personally haven't used it on a job, but I've seen videos of that, and I was talking to somebody in Europe about it that's trying to get over what was that guy, Bam or something like that? Yeah,
It was so amazing.
yeah,
So it's literally the same thing that you're saying, but it was a carpet roll.
yeah, yeah, yeah. When you said rolls, I went straight to
The
that
mesh.
small wire mesh stuff that you used to roll
Nice.
out, but it comes in sheets too now, but yeah, no, I've seen that, that's pretty cool.
Yep.
Yeah, I talked to that guy, and I gotta catch back up with him. It's been a while since I talked to him.
Right on. My number 4, modeling and simulation. Man, my heart goes to beat, especially with our if you look at the basics, hold on a second. There's a lovely book that goes into the matter behind our models and our simulations, right? And I have a wonderful presentation on how one of these software packages work, but we said no product names. You need to grab this book.
Okay. Is that a book you got to have a PhD to read, or
I was
can it
just about to say no, because I did not have my PhD when I read this book. But nobody's going to test you on this information. But what it does is it gives you the background as to you have these software packages, these modeling software packages, everything from bridge oscillation for earthquakes to the size of a girder or a beam for a house based on the load to concrete mix design, curing in different situations for both phase development as well as mechanical properties. That type of stuff. The problem is you went to reduction of labor force. I'm going in the same direction that we have a reduction in labor force. We have a reduction in labor force everywhere. Listen to Mike Rowe, and he goes, when they say they should have sent a poet, when it's talking about the reduction, not only in the labor force, forget the labor force, people care, right? You and I
Yeah.
aren't perfect, right? We're students. We're trying to become better. Shoot, I just screwed up on a series of projects in the last few weeks. That's why they put erasers on pencils. But there's less of us out there who care. So we have to recognize other tools. Modeling and simulation. I'm looking at pipe flow, modeling and simulation. I know that doesn't sound exciting, John. Get it. You have every right to say that. But
I didn't say it.
okay, that's the general public. That was not you. If it was going to be you, I would have said, that's not how I said. Like I would have done that voice. That's more
Yeah.
your voice. The modeling and simulation software out there is so powerful that if you just do a little bit of research out in the field or the lab or combine the two, and you can find what's the word I'm looking for? A consistency between the data. Like now, all of a sudden, what would take you 50 days, 90 days, 2 years, you can model and stimulate and get an idea of what you want to do. Will it have a general idea, a modeled idea, or simulated idea, excuse me, in a short period of time? And what we do is a lot of underwater abrasion for pipe flow,
Mhm.
right? And as it turns out, concrete water pipes do great until there's a certain amount of turbidity, right? And whether turbidity is rock sand, I just got the meanest stare from my dog right now. He is disappointed. So if there's a little bit of turbidity, now all of a sudden we start wearing and tearing the rock or the concrete faster, and then we start ripping and stripping the rock, and then it goes to hell. We can stimulate what that looked like, the profile, what is that N value, that epsilon value that you have in your turbidity equation or your Reynolds number equation, or your, what is it, your frictional flow equation, your H of S, F, you know what I'm talking about?
I don't.
Your head friction from water flow takes into account the Reynolds number, which is a water flow number that goes back to whether it's laminar or turbulent flow, right? There's a certain value in there. It's called epsilon that goes through the type of water you have, like good water, clear water, or deer carcasses or soil in your water.
Mhm.
The more turbidity, the more it's going to tear down your concrete. Now, if we can connect that to tests that we've done in the field or tests that we've done in the lab on certain concrete mix designs and say, hey, we know at this and this times under turbulent flow, this is what happens to our concrete. We put that into the model. It'll tell us how the water flow will change based on the feel of the concrete because of that abrasive wear. And that's all we could do the same thing for 3D printing with the flow of the concrete through the pipe. Tyler Lay did a similar thing where they tested how air changed through a pipe, right?
Mm.
Now you can create a model or simulation in a software package in a model to tell you how different mixes will interact based on the change in bends. So there's so much you can do, but our industry is always, nothing will replace what you do in the field making concrete. No, Sherlock. But we just don't have that many people. So we need to be comfortable with different tools.
Yeah. Does that modeling, could you take, say, a project and model what I if it would, I guess I should make this less complicated. Say you have a project that's reinforced with traditional rebar, and you wanted to see if you could reduce the amount of rebar in the structure and put
Right.
post-tensioning cables in place of
Based on
some
what
of
you
the
do in
reinforcement.
concrete or something.
Is there modeling for that?
So many models, but BUT, no, BUT, this is the reason why you have to get into this.
Yeah.
Because the problem is, and I love saying it like that, the problem is garbage or good data in to a bad software equals garbage out. So if you don't know, like you could be sold a real lemon. I don't know what other word to use, but a real piece of crap software that when you're doing software or modeling, what you're doing is you're stimulating what would happen in the real world by using equations with the data you've given them based on a certain amount of parameters, right? If you set up the parameters wrong or your conditions are not set up the right way, it doesn't matter what you put in, you're going to get garbage out. So understanding how these models work is important because if you don't If the designer of the model screws up the logic, doesn't include the right factors, or doesn't give you a chance to change up factors, you might be consistent. That's the great thing about models. You put data in, you will consistently get data out, but you can get consistently wrong data. So that's why it's important to do. We're releasing a concrete mixed design software package. And it's not for the everyday homeowner. Man, oh, John, why don't you make it? Because I don't deal with it. That's not what people say, nor is it how they say it. My dad said it like that, or not my dad. My dad is actually all for it. He normally says stuff like that. I had a buddy who said, well, I don't know concrete mixed design, so I don't understand it. I'm like, great. I don't want you to buy this.
It's not for you.
Right. This is for people who understand concrete, but don't know how to design it or have a hard time designing it and just want a backup check. And I think it's 99 cents a month. It's a software package. It's a model, and it's simulating what's happening in the real world. Can you use it? No, it's a benchmark, right? And all it is a bunch of equations that are generating a response based off of user input. Okay. So modeling and simulation, freaking love it. Number 3.
My number 3, I will go with concrete sensors. The sensors you put in concrete that measure the temperature of the concrete. So before, can't remember if I've done a podcast on it. I think I have, but so essentially what you do is you make a bunch of cylinders and you break cylinders at 1 day, 3 day, 7 day, 28 day. You measure the temperature and then you correlate that with the temperature and your concrete in place, and it tells you the strength of the concrete, which was pretty cool. First time I used it was 2004, and I can count on one hand how many times I've used it since.
Oh,
But it's pretty cool technology.
why do you think the industry doesn't want to adopt it versus why they should adopt it?
They're just used to making cylinders on site and dragging them to the lab and breaking them and going with that.
Put in a thermometer in there. That's the temperature. I'll put it in the slab if you need me to. We can leave
Yeah.
it in there.
Yeah. Yeah, and you can yeah, the cylinders, I think we beat up cylinders a bunch on the podcast, a bunch of episodes. But, yeah, you can make those cylinders break at whatever you want them to,
Oh, come on.
and when they're mishandled, they never tell you what really is going on,
Wait a
so
second. Don't blame the cylinders.
No, I'm not blaming the cylinders. I'm saying that y y I'm there's many problems with the way we typically test the concrete.
You know, I'm sorry to say this, but and I don't mean to say it this way because I'm being
Uh-huh.
disrespectful to myself. Greater people made greater concrete structures that have outlasted our great grandparents with lesser technology.
Yeah.
And to demonize, I'm in love with cylinders.
Of
I'm in love
course
with
you
cylinders.
are. You're a lab guy.
No, I'm not. I'm a field guy. I've gone to the lab where
Yeah,
I started out as a 14-year-old kid, was out in the field. So
right.
I went to the lab. But for Lafarge North America, my ass was up at 4:00 in the morning grabbing aggregate for under the way up hopper in the plant and following trucks out there and taking samples and making sure water wasn't added. I love cylinders because they are a great tool beyond what the standard tells us. What you've just told me is, and I'm cherry picking your words, so I do apologize, but people don't care of it. They're mishandled. Whatever job site you were on where that happened, somebody didn't give a about doing their job. Excuse me. I apologize. Somebody didn't care about their job. I won't cuss again. I promise. I'll do a better job. And that's data set. That's important to have. That doesn't mean that the concrete was bad and we have, ways of Swiss cheesing the concrete. That's another discussion. That's not how we make Swiss cheese, by the way. We don't drill holes into Swiss cheese to make Swiss cheese. But there are ways to determine if the concrete is really good or not. But I agree with you, that happens. That doesn't mean it's not good data. I just don't like the idea of demonizing something that is at the foundation of concrete mix design. Granted, it's not the concrete that's being placed. It's not supposed to be. It's supposed to be a metric. That's all it's supposed to be, a tool that we use to determine how did we do with, because all we are is a delivery service on the ready mix side. We're transportation. Just happens to be that we transport a perishable material as a window. If you don't get it in that window, you're up the creek without a paddle. What we need is a third party to altruistically, they're getting paid, but altruistically tell us, how did we do? We did bad. All right, tear it out, guys. We screwed up something, or time out. Right? And people are trying to automate cylinders. And the unfortunate reality is you're just not allowed to do that yet, unless you have a PE stamp it that you can do that. But a lot of sensor folks, and I'm in love with sensors, I think they're great, but a lot of sensor folks are saying you can replace. Do you mind sending that puppy outside? He's mad at you. He's not mad at me. They're trying to, literally everything you said, brother, has gone back to the reduction in labor force, a higher quality product, right? Sensors were never meant to replace concrete cylinders. I know a lot of people are selling that. Saves you money, saves you time. But ASTMC 1074 stipulates, maturity of concrete stipulates that you need to have some type of secondary method, whether that's concrete cylinders, cast in place concrete cylinders, a Windsor probe, or maybe that was taken out, a rebound hammer, but you need to have something that's a secondary, gives you secondary information on what's going on. Because maturity and temperature is only correct to a certain degree. It's like a model in a simulation. You can't just use modeling and simulation, right? To go out to a job site, we have to do some concrete mixes. So that's my only thing. But I understand why you like concrete sensors from your side. I just think that we need to hold our practitioners, our contractors, our testing firms to a much higher standard. And that's another conversation.
Yep. That's fair.
Okay. You ready for mine?
Yep.
You can beat me up on this one, okay?
Okay.
Hydrogels. Love
Hydrogel.
hydrogels.
Yeah.
Fucking everything in concrete is a flippin' hydrogel, right? Like the calcium silicate hydrate network. It's a ham and cheese sandwich. It's a hydrogel. Like the makeup of it, when you look at it on a nanoscale, looks like a ham and cheese sandwich, where your piece of ham is a calcium oxide layer. Then you have your cheese, 2 pieces of cheese on either side of your ham, which is your silicone tetrahedron. And then you have your bread, which is, so this is pairing silicone tetrahedron. And then you have bread, which is your pairing silicone tetrahedron. And then you could do a Dagwood Bumstead sandwich and put a little mayonnaise on top of it and another sandwich on top of that. And you have stacks of calcium silicate hydrate. That's a hydrogel, right? Alkali silica reactivity. It's a hydrogel, right? The stuff that we work on with colloidal silica to rejuvenate or damaged and deteriorated concrete is a flippin' hydrogel. Like even calcium oxychloride formation to a certain degree is the pacification layer over steel is a hydrogel. Love hydrogels.
And what do hydrogels do for
They
concrete?
destroy concrete as an ASR gel, the depacification of rust over steel, and they can be used to heal concrete. We're an industry that understands so little about them. The medical industry has been using them for decades, and we follow suit with a lot of the medical industry. It turns out our human body solution is a similar makeup to the concrete pore solution. It just happens to be that way. So there happens to be some similarities between the way that we can work with concrete. Look at the Department of Defense just released $10 million to the University of Utah for the US BRACE DARPA program, which BRACE stands for Biological Remediation of Aged Concrete Edifices. And they're basically using the same vascular systems that we have in our body to try and repair concrete.
Huh. Mind blown.
We have a $42 trillion debt on concrete that needed to be replaced yesterday. Structurally deficient concrete, and that's only looking at bridge, dams, locks, levees, spillways, like the important shit, right? And the reality is we can't replace it. We don't have the people, resources, and we don't have to get Mike Rowe's poetry into it about our labor force, but we have not yet automated construction as they've done in the movie like Tomorrowland with George Clooney. Terrible movie, but we just haven't done that yet so that we can replace structures quickly. A direction of using hydrogels to biologically rejuvenate aged concrete.
Yeah.
Now, there are companies that make a product that is the kryptonite to concrete, because that's what we're talking about. There are fake companies out there that they say they have the same thing. And that was my big discussion with different entity folks. How do you tell the good stuff from the bad stuff?
Mhm.
Because again, ASR is a hydrogel. Bad stuff.
Yeah.
What's your next one? We're running out of time.
I got, I guess, go with 3D scanning and building information modeling is so that technology was around, but it wasn't really used for concrete till I guess the last handful of years. It's really hit mainstream. We've used people have heard BIM, what BIM is.
Right.
We've but it just makes it so much easier to visualize what a building looks like, what a structure your building looks like. It makes it a lot easier on everyone involved with the project to see what the end result's supposed to be. And also with the 3D scanning, you can immediately see, and even there's some guys out there that are scanning, and we're doing that too. Baker's doing that, is scanning concrete while you're placing it down, so you can see if there's any issues with it being flat and stuff. And then you can scan in place, even going to the other trades like MEP, mechanical, electrical, plumbing, conduits and pipes that are sticking up. You can go out there before you pour concrete, scan it, and then compare it to what the plans and see if there's a issue out there. It's fantastic technology.
I want to buy one of those. I know exactly what you're talking about. And I spoke to that guy and that lady, and I fucking want one so badly.
Yeah.
Like, come on, wait, it's only like $35,000 and $1,200 a month for the software package. Like, totally. She's like, how would we use it? That doesn't matter. It's cool. It makes me jump out of bed in the morning.
Yeah. No, it just makes so much. It makes so many things. We could sit here for the next half an hour and list all the things that it does for us. But yeah.
All right. So you realize it's all going back to this reduction of labor force, higher quality, like everything you've chosen so far has gone back to that some form or fashion.
Yeah. In concrete construction. So that's a bit always top of mind.
Understand. All right. My number 2, you ready?
Yep.
Colloidal silica for concrete.
Okay.
I'm going to fall out of love with that.
I'm just going to jump and say that was my number 1. So we can talk about why for each one of us. For me, and I'll let you say you're going to talk more about it than I am. I just got my hands on some in the last couple of weeks.
Great stuff.
I've shared with folks, I'm doing concrete countertops at my house and just playing around with it on on
All you need is
that.
a little bit.
Yep. So I what I'm most interested in with colloidal silica is internal curing, getting rid of any wet curing requirements on a project, and also the chemical cures that we use right now.
Right.
I'm not a fan of. I don't think people use them like you're supposed to, and I don't think we're properly curing concrete. So I really like the aspect of internal curing. That's
I
why I
would
like
love to
colloidal
do
silica.
I'd love to do a sidebar conversation on that since we've done a lot of research. And I even have a paper that we're writing and publishing that if you promise not to share it, I'll send it to you for an early. It's almost like Harry Potter adventure. It's like just riveting. It's just
Yeah.
riveting on colloidal silica and internal curing. It's one of my favorite subjects about the technology.
Yeah. Yeah, I didn't mean to jump ahead, but since your number 2 is my number 1, and I think it's just honestly, it's my number 1 at this point. My opinion of it is still I'm on the fence, because I haven't used it in the field and seen what happens. I have my little project at home, and they'll show me a little bit of it, but I think that is the technology that's top of mind right now because it's the newest thing that I've looked into.
And I love it because this is not a new thing for me. I've been studying this stuff for, I keep saying a decade, but I think it's been 17 years now. So it's been 17 years now, and I am deep into the research. The plan is for me to start a postdoctorate this month, furthering my education, answering more questions that I want to answer about colloidal silica. But we're barely scratching the surface, man. It's almost like how we started with, it's the same conversation about starting with cement in 1847, right? When Joseph Aspin like first really created this patent of all you got to do is add water instead of adding all these other things or just getting one type of natural cement from some part of Pennsylvania. It was, to me, colloidal silica is really where I found my home for research and development. I felt very comfortable. And early on, people would just laugh at me. I had to bribe people to send me samples. I annoyed the shit out of people when I asked for samples. So it's been a very long journey. And I don't think I'll ever stop. Once I retire from concrete, I'm sure I'll still keep reading about colloidal silica. So, yeah, I love it.
Yeah, and there's many things it does beyond internal curing, which I think there's a lot of products that we apply and put in concrete right now that it can replace and do many more things. So there's possibly a cost reduction and labor reduction there as well.
Yes, and yes. And that always goes back to you for that reduction in labor. That's awesome. But it's also, let's say, fly ash. I fully embrace that class F fly ash that you and I started using when we were younger is dead. What we have right now is bastardization of what we used to call fly ash, and that's the chemical and physical properties. It's not my opinion. That's just numbers. Using colloidal silica with what is now considered class F fly ash makes it seem like what we used to get in the late 90s, the early 2000s, the poor man's water reducer, the pozzolanic reactivity that you wanted. And that's when you're combining the two.
Mm.
So I think that for engineers that aren't comfortable using anything but class F fly ash, because that's what their predecessor used, great. They can use colloidal silica, small amount, plus the fly ash. That's not really fly ash, but keeps them comforted. So yeah, we
All
ran a
right.
huge project, 300 yards in Colorado doing that for what was Martin Marietta. And that's literally all we did. So
Yeah. All right. We skipped to my number 1. What's your number 1?
my number one, it's going to sound hokey. My number one is concrete. My number one is concrete.
I think
It's my favorite part about concrete technology. And if you want to argue, let's run a new concrete technology, I dare you to ask any ready mix provider about their day to day activities. Because even that 3,500 PSI exterior flat work mix for a driveway is brand new every flipping morning, whether it's the cement chemistry, the gradations, the temperature of the day, the person behind the batch computer isn't wearing the right plaid shirt, whatever it is, making concrete is not the easiest of occupations out there because it can be an ever changing, it's more of an art than a science. And as you have pointed out, the reduction of labor force, we're trying to automate a lot of things. AI software can't replace a fighter pilot. AI software, in my opinion, cannot replace somebody who is designing and managing concrete 100%. There always has to be some human element to that.
do you think that F-35 that we lost this week was flown by an AI?
It's not my business anymore, man. I'm out of that business. I retired from that business a long time ago, man.
Well, I like where you ended with concrete. I agree, and yeah, and concrete can be an answer to more and than just building things too, I think. But we can talk about that on another episode because that's another hour conversation.
There was
But
one other conversation that we started about, I think it was about responsibility in the field.
Mm.
And that's something I'd rather talk about. I want to talk about colloidal silica with you and dive deep into some of the research and the concepts. But I think responsibility in the field, one of the things from my postdoctorate is they asked me to put, what do I want to be when I grow up on there? And I want to be part of the NCEES board. I want to develop a PE, professional engineering exam for concrete. There's one for water, for transportation, for soils. Freaking soils. They have a freaking stupid PE. And by the way, I'm a geotechnical engineer, a licensed PE for stinking soils, right? Why wouldn't we do it for concrete? Concrete is so much tougher. And I already see the whole breakdown. 80 questions, baby. Or excuse me, 40 questions. Whew.
yeah, that sounds good. We could start the Dr. John School of Concrete. Sounds awesome. All right, man.
That's
Well, as always, I appreciate you coming on the show. Folks can reach out to Dr. John Belkowitz via LinkedIn, Intelligent Concrete, Eddie Stone, and anywhere else I forgot.
Those sound good. That's enough. Yeah, any
Okay.
questions? Just not on Sundays. That's family day.
You you say that, I get texts from you.
But you said Whitney's sitting right here, man. I'm gonna get in trouble.
All right, man. And thank you, and everybody keep it concrete till next time. Thanks.